All right, hello algebra students. This is Mr. Pouts, and this is the answer key video for the Chapter 3 practice test. So I'm going to go through each one. It might be a longer video than normal. It actually will be a longer video than normal, but this is for you to use at your leisure. You can skip around on it and make sure you're ready and prepared for this test. So I'm just going to go through it one by one. So let's start with part one. Write an inequality for each graph. Write your answer then in set builder notation. So I'm going to first write the inequality. It's an open circle and it's going to the right. So x would be anything greater than, not equal to, -3. And set builder notation, you'd be writing it like this. You have the fancy brackets, and the variable you're using, and then the inequality. And you close the brackets. Okay, so that's number one. Number two, the inequality, it's going to be less than or equal to, because x is anything less than or equal to 1. That's going to the left. And set builder notation would be x such that x is less than or equal to 1. All right, number 3 and 4, opposite. We're going to actually graph them. So the first one, x is less than -6. So you're going to have to label your graph. We'll say this is 0. We'll say this is, well, we could say -2. We'll go by 2s. -4, -6, this is 2, 4, 6. All right. Less than means it's going to be open circle at -6 and going to the left because it's less than -6. Now number 4, before you can graph it, you got to write it with the x in front. So rewrite it so that x, flip the symbol, greater than or equal to 4. 0, 2, 4, 6, -2, and so on. A closed circle at 4 this time. And it's greater than or equal to it, so it's going to the right. All right, section 2, solving using addition or subtraction. So we're supposed to solve for x. All right, number 5, and it says right in set builder notation. So number 5, I'm going to solve number 5 by getting rid of that -2 by adding 2 to both sides. Yes, 6 is greater than or equal to x, and we flip it around and have x is less than or equal to 6. Written in set builder notation would be with the fancy brackets, x such that x is less than or equal to 6. Okay? Number 6, solve for x. This is addition again. It's +7, so we're going to subtract 7 from both sides. Cancel that out. So you have x left over here, less than 3 minus 7 is -4. Written in set builder, we have the fancy brackets x such that x is less than -4. Number 7, x minus 3. Gotta get rid of that -3 by adding 3 to both sides. So you have x is left over here, less than or equal to -9 you'd have. And here's set builder notation. All right. And then number 8, we have to get the x by itself again. So add 4 to both sides. With the x left on the right side, we have 0 like this. Not written correctly yet, so let's rewrite it with the x in front. X less than 0. In set builder notation, you'd have x such that x is less than 0. All right, moving on to section 3, bottom of the first page. Solving by multiplication or division. So number 9, we have division. So we're going to multiply both sides by 3. Times 3 on that side, times 3 on this side. Cancels out, so you have x is greater than -4 times 3 would be -12. And in set builder notation, it would look like this. All right, second one, number 10. We're going to have to divide here. We have multiplication, so we divide by that -2.2 on both sides. You end up with x is we're dividing by negative, so you switch the symbol. Remember, negative rule. And that would actually be -5. So you write this in set builder notation with the x, such that x is less than or equal to -5. Number 11. Now, number 11 is going to be 2 steps. It depends how you do it. You could divide both sides by -2/9, but I want you to round on your calculator because that will change your answer a little bit. So we have 2 things here. You can multiply both sides by 9 since we have the division, and do that right away. And then you're just left with -2x is less than, this is going to be 324, I believe. And now we have to divide, so we're doing it twice. So now we have the -2 that's in front of it and divide by -2. When you divide by negative, don't forget to change the symbol. And I think it's -162. And in set builder notation, it looks like this. All right, and then number 12. We're still trying to get the x by itself. Don't even worry about that 3x. If you want to change that to a decimal, you could write it as -6x is less than or equal to, I think it's 0.375. All right, but you divide both sides by -6. Okay, and you have x, change the symbol again, negative rule, greater than or equal to, I think it's going to be -0.0625. We can check that. I've got a calculator on here, I believe. I hope. Pull up my calculator. 0.375 divided by -6 is -0.0625. So I did remember correctly. So there you go. Now you just have to put that in set builder notation. X, such that x is greater than or equal to -0.0625. So that's page 1. We're going to page 2 now. Page 2 has some multi-step inequalities. So it says solve each inequality if possible. Write the inequality, or if the inequality has no solution, write no solution. If the solutions are all real numbers, write all real numbers. And I'm going to actually say you don't have to write it in set builder notation for right now, especially for space-wise here. So we're not going to write these in set builder notation. But remember, same steps apply if you are solving a multi-step equation. First, you need to look to see if there is any distributing. And right here we do for number 13. Distributing and like terms. So on this side, we're going to have 2x plus -4. On the left side, we can combine some like terms. So if we change these to plus a negative and plus a negative, the like terms would be 5x and -3x. So you have 2x on that side plus -6. All right, now everything is simplified on each side, so we need the variable terms on the same side. So let's get rid of this 2x right here. So let's get rid of it from the other side as well then. This is going to come down with us. This cancels out, so you just have -6. This also cancels out, so you just have -4. No variables means it's going to be either no solution or all real numbers. So ask yourself, is this true? Is -6 less than or equal to -4? Yes, so that would mean that there's all real numbers. All right, on to number 14. Number 14 is just going to be a 2-step one, I believe. So we have 8 minus 7x. Let's change it to 8 plus -7x. And greater than 15. So let's get rid of the constant first. So -8 from both sides. So we have -7x is still over there. Greater than 7. All right, and then to solve for x, divide by -7. That changed it because of the negative rule. So x is less than -1. So there's number 14. Number 15. Nothing to simplify on the left side. On the right side, we have a -5x and a plus 8x. So we have 2x plus 7, still over here, is greater than, that's going to be 3x plus 30. So, variable terms first. Get them on the same side. Let's get rid of the smaller one from this side. because then we're dealing with positives. Okay? This is gone. If 7 is greater than 3x minus 2x is just going to be 1x, or just x plus 30. Last thing you got to do is subtract 30 from both sides. And you have x left by itself, and this is going to be negative 23. Rewrite it, though, so that you have the x in the front. X is less than negative 23. Number 16. Ooh, number 16 is a nice long one. So let's use our space wisely. So I'm distributing first on both sides. So on the left side you have 3x plus negative 12 plus 4x minus 2 is less than 7x plus negative 49 plus 12. Just want to check make sure that was a 7. That was a 7. All right. So on our two sides, we can combine some like terms. 3x plus 4x over here. We can do negative 12 and negative 2. So we're going to have 7x negative 12 minus 14, or plus negative 14. This side, we can combine just the negative 49 and the plus 12. So we have less than 7x. That's going to be plus negative 37. Okay? All simplified, so let's just get the variable terms on the same side. So we'll subtract 7x here, and you got to do it on this side as well. That cancels out too, so we have negative 14 is less than negative 37. And is that true? It is not, so there is no solution. All right, now number 17. One big long division problem there. So to get rid of the division first, I'm going to multiply both sides by that 5 to get rid of that division. That would be what you'd have to do first. So we have 2x plus 7 is less than or equal to 5 times 5 is 25. Now we just have two steps. Minus 7 both sides. And then divide by 2. So x is less than or equal to 9. And finally, number 18. Looks like there's some distributing on both sides. So change this to plus and negative. Plus and negative. So we're going to distribute the negative 2 to both of those. So we have 5x plus 10 plus, this is going to be negative 2x plus negative 2 times negative 1 is actually going to be positive 2, greater than or equal to 7x plus 4. Now before we can get the variables on the same sides, there is some combining like terms. They're positive 10, positive 2. So we have a total of 3x plus 12 is greater than or equal to 7x plus 4. Okay? Getting the variable terms off of one side would be getting rid of the smaller one. You could do either way, but let's get rid of the smaller one. Then we have to do that to the other side, minus 3x. So you're left with 12 is greater than or equal to 4x plus 4. Subtract 4 from both sides. We have 8 is greater than or equal to 4x. And then divide both sides by 4. And you get x and 2. Rewrite that for your final answer so that the variable is in front. We'll say x is less than or equal to 2 because you flip it all. So that would be section 4 on multi-step inequalities. So let's move on then to section, well, we're skipping section 5, so section 6. Got a few here. Section 6 is dealing with compound inequalities. The first one we have here is an or, the second one is an and. Solve each one and graph, and write it in set builder notation. So 3 parts here. First one, looks like this is solved. We just have, I'm going to rewrite it so x is greater than negative 4. That's one of them. And we have this one, we got to actually do some solving. Minus 1 from both sides. So we have 3x is less than negative 3. Divided by 3 on both sides. We have x is less than negative 1. So there's our 2. To write this in set builder notation, we have the fancy brackets. We're using x. And the inequality, or the compound inequality is x is greater than negative 4, or x is less than negative 1. All right? Close the brackets. Now, we're going to see something interesting with the graph. Let's just make sure we have enough on here. So 0, negative 1, negative 2, negative 3, negative 4, negative 5, and so forth. Both of them are going to have open circles. We have at 4. So the first one is x is greater than negative 4. So that's going to actually go this way. Second one is at negative 1, and that's going to go this way. So you see they overlap, and usually OR inequalities don't overlap. But when they do like this, and they're going in opposite directions, they're covering the entire line. So really, in here, we'd say this is all real numbers. And you can put all real numbers in the in this part right here. Okay? That would be our OR one that we have right here. Second one we're going to do is an AND. So I'm going to rewrite this one. So actually this one you just solve by dividing by 3 on both sides. X is less than 2. And we'll rewrite this one. X is greater than negative 5. So we have, we'll have negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. So x is less than 2. Going this way. X is greater than negative 5. Going this way, and we're looking for the overlap. So and ones we're actually looking for the overlap. So the overlap would be right there. And to rewrite that, you could rewrite this thing so that you have the x in the middle. You have then 2 on that side and then negative 5 on that side. And I'm going to write this in set builder notation. We're using x such that x is between 2 and negative 5. And there you go. So that's all of page 2. And we're going to finish up strong here with page 3. So on page 3, number 21 and 22 are also from section 6. So, number 20 says, write the compound inequality that the graph would represent. Write the answer both in set builder notation and in interval notation. So, looks like this one is an OR because they're separated. So, sorry, as I was saying here, you don't have to write like this, but the first one, this inequality is x is greater than 1, and this one is x is less than or equal to 0. So to write that in set builder notation, it's an OR. We're just going to write it. We're using x such that x is less than or equal to 0, or x is greater than 1. Now, in interval notation, we're still going to have 2 of them. We'll have to write one for each. Interval, remember, you use parentheses if it's a less than or greater than. You use a bracket if it's greater than or equal to or less than or equal to. So if you look for the first one, x is less than or equal to 0. And really the graph might help. So 0 is a bracket because it is on the right side of this part of the graph. So we're looking at this part of the graph. It's on the right side, and we're using 0. It's filled in. The other part is going forever to the left. So really the other endpoint is, there is no endpoint, so it's negative infinity, and we just leave it as a parenthesis. Now the one on the right, if we're looking from here to here, the left endpoint is 1, and that's also a parenthesis because it's an open circle. And the right endpoint, it goes on forever, so it's a positive infinity. So that's our interval notation. All right, now 22. The speed limit on the road is 55 miles an hour. The police officer is usually using a radar to monitor speed. He allows people to exceed the limit by 5 miles per hour or drive under the limit by 10 without giving them a ticket. So write a compound inequality representing the speed which drivers can travel without getting a ticket. So if your speed, we'll say x is your speed. So if your speed is x, you can go all the way up to 60. So 60 would be the farthest right, all the way down to 10 below, so that'd be 45. And that makes us an inequality. Could it be equal to 55 or 45 and 60? Yes, it could be. So you put less than or equal to there. And it's just a and compound inequality. All right, last section. Section 7, absolute value equations and inequalities. So, number 23, solve, graph, and write in set building notation. So to solve an equation, an absolute value equation, and if the absolute value part is by itself already, we just make two different equations. So it could be equal to 9, the part in the middle could be equal to 9, or the part on the inside could be the 3x minus 6, whoops, I mean 3x minus 6, could be equal to negative 9. So you solve each of those by adding 6 on both sides. If 3x equals 15 divided by 3, x equals 5. Same thing here. 3x equals negative 3. X equals negative 1. So if you were to graph that, you just have to have 5 and negative 1 on there. So if we'll say this is 5, 4, 3, 2, 1, 0, negative 1, negative 2. So we'll put the point at 1 and 5, negative 1 and 5. Set builder notation, I'll write it above. Still the same thing, x such that x equals 5 or negative 1. All right, the other two are inequalities. So one is a less than or equal to, one is a greater than or equal to. Now remember, if you have a less than or equal to, we're going to make a compound inequality that would be an and. So we're just going to put that x plus 4 in the middle here. Use the less than or equal to symbols. The far right will be the 10, the far left will just make that a negative 10. And then to solve it, you minus 4 from both sides, or all three parts. So you have x by itself, 6 and negative 14. So I'm going to go by 2's here in our graph. Just so you know, the set builder notation for this would be x such that you just put the inequality in there. Okay? But I'm going to have negative 14, negative 12, negative 10. So it'll be 8, 6, 4. Well, let's say this goes all the way up to 6. I don't know if it was going to work out otherwise. But we have closed circles at both, and since it's an and, we're looking for where they overlap, which would be the connecting part. And the last one, number 25. 25 is greater than, so that means this is going to be an or. So we're going to do 2x plus 6 is greater than or equal to 36, or 2x plus 6 is less than or equal to negative 36. And then you have to solve each one and graph them. So minus 6 for 2x is greater than or equal to 30. X is greater than or equal to, we'll divide by 2. Whoops. You end up with x is greater than or equal to 15. All right. And this one right here, minus 6 from both sides. If 2x is less than or equal to negative 42, divided both sides by 2, x is less than or equal to negative 21. This is an or. So this would be our final inequality, and you have to graph it then. So as long as you have, let's say 15 is over here, negative 21 is all the way over here. I know it's not perfect, but or closed circle at both. So if we're saying greater than or equal to 15, that's going to be going this way. Less than or equal to 21 is going to be going that way. So there's the graph. Oh, don't forget about set builder notation. X such that X is greater than or equal to 15, or X is less than or equal to negative 21. And that is the answer key for the practice test for Chapter 3. Hope it helps. Feel free to, again, jump around, look back at what you need to fix, and use this as a studying tool. We'll talk to you later. Good luck studying.